Okay, we're live. So welcome everyone to our 80, 90 something meetup. And today we're going to be talking about Docker and how Docker is applicable to Java developers. Now, I welcome Arun Gupta to the virtual jug, or should I say back to the virtual jug. How are you doing, Arun?
I'm doing very well, Simon. Thanks for having me here.
Awesome. It's always a pleasure to have you on the VJug, Arun. Now, Arun, you gave a session on Docker a while back, and so this is actually going to be a refresh now as to what's changed, what's new, and also for new people, I guess, as to how they can get started with Docker and Java, right?
Right, correct. Because that session that I gave was almost 2 years back, and Docker has vastly improved since then with lots of new features and tools. So I thought I'll give a quick overview of what's happening.
Awesome. And Oleg, you're joining us as well from Tartu in Estonia. How are you doing, Oleg?
Hi, people. I'm doing great. Very excited to be here.
So if you could, over the next minute or so, if you could just make sure everyone's connecting correctly. And what I'll do is I'll just share, let me see which one I'm going to share. I'm going to share this screen, and I'm going to go full screen here. So hopefully you can see my slides.
Yep.
Cool. So this is the session, Docker for Java Developers Refresh. Arun Gupta is our speaker, and you can follow Arun on Twitter. There are still people who don't follow you, Arun? I don't believe it. You can follow Arun at Arun Gupta on Twitter. Just a quick mention about our Java user group sponsor. Zero Turnaround is our sponsor, and Zero Turnaround create revolutionary developer tools. You are welcome to check out JRebel and XRebel. JRebel is a tool that allows you to reload your code changes instantly, so you don't need to redeploy or restart servers or JVMs. XRebel is a tool which is a Java profiler. It allows you to check your performance of your web applications in real time while you're developing them. So do check them out. You can go to zeroturnaround.com and get free trials of both of those. So if you're new to the VJug, which I know many of you will be because a lot of people I think have signed up through the meetup site with the Virtual Jug 24 conference in mind, and this is their first session, so welcome to the Virtual Jug. You can chat and ask questions through IRC. If you are on virtualjug.com, which I expect most of you are, next to the live session YouTube widget, you can log in through the IRC widget there, and that will automatically log you into the channel Virtual Jug. You can also do it through any other IRC client. We're just a free node channel. And you can ask, as I mentioned, you can ask questions there and also discuss the session and topics with other people in the Virtual Jug. So please do share this group, share this session, tell everyone that you're on this session on Twitter or whatever your favorite social network is, and we'll get more people added onto this group. We're almost at 10,000 VJug members now, so the group is really getting large now. And as always, if you wanted to give any feedback about this session or the Virtual Jug in general, you can tweet at Virtual Jug or myself at sjmaple, and I can take your feedback or suggestions or whatever else you want to tweet on Twitter. So just a reminder, the Virtual Jug is running a 24-hour conference, which is 24 sessions back-to-back on the 27th of September, which is just 2 weeks away. We're going to be starting at 3 a.m. Eastern Time and finishing 3 a.m. the next morning. So that's going to be a tough challenge, but we've got 24 amazing sessions for you. So do check that out, vjug24.com for more information. So without further ado, let's hand over. Oleg, I assume everyone's connected all right and everything was good?
Yeah, I think everyone is watching. We had a slight problem with one user, but I feel like they resolved that. So the video looks great. People are in the IRC following the session and ready to go. Awesome. We have a couple of people joining from Target in the US, and if you're watching from somewhere else and you want to share this experience of watching Virtual Jug with your colleagues, this is a great example. You can gather as a group and watch the session together.
That's awesome. And also, just a quick shout out actually to a group in Belgium. I believe they're doing exactly the same thing, and they're providing food and drinks and all kinds of things. If I can grab a quick name here, Dieter from Ordina, Belgium. So hello to there, and it's a join event. So yeah, hello to people there, and enjoy the session. So Arun, I'll pass over to you, and we'll be monitoring IRC for any questions or discussion.
All right, awesome. Thank you so much. Hello to Dieter as well. I will be joining them in a few weeks, actually giving a repeat of this, personally for them. So, hello again. Okay, all right. So I'll share my slides here. So I'm gonna go here. All right, and you can see my slides now?
Yep, we can, that's fine.
All right, awesome, cool. So hello again. My name is Arun Gupta. I run the developer advocacy team at Couchbase. Couchbase is a NoSQL database company. If you're looking for an open source NoSQL document database with key value, mobile, and all those cool things, that's when you're looking for Couchbase. Today the talk is going to be all about Docker for Java developers. So what am I? I'm an avid runner. I like to run. I run quite regularly, and I also believe we should educate kids, in an early age, expose them to STEM technologies at an early age. As part of that, I started DevOps for Kids effort earlier, about 3 years ago actually, and I also authored a book with my son when he was 11 years old for O'Reilly. So super proud of that. But the kind of things we need to do to enable the next generation is very important. So let's jump into the topic itself. What is Docker? Well, Docker is synonymously used with the term containers. Containers are basically giving you the ability to package your application in a very operating system agnostic way. Think of it that way. It simplifies building and packaging and deploying and running your applications. But what is Docker? Well, Docker is an open source project that used to be called as .cloud. It was a French company. That's where its thing started. Then the name got converted to Docker. Now it's an open source project backed by the company called as Docker Inc. And if you look at the number of stars and forks and watches in the project, immensely popular, huge growth in the ecosystem. It allows you to create containers for software applications. Now, with the Java world, we are familiar with the concept of WORA, okay? So how does it give us WORA? Well, WORA is write once, run anywhere. You have an archive, jar, var, year, whatever it is. You package that archive, and it can run on any of the operating system because there's a JVM underlying which understands that archive or the bytecode format and runs it. In a similar way, Docker gives you PODA, or called as package once, deploy anywhere. Now, that comes with a caveat, but first to understand the basic concept, Docker gives you a portable image format. In that image, you can package your application with all the dependencies. And then that image is then interpreted by Docker runtime or Docker engine, which is where the container is run. So image, in that sense, is where you build the whole thing together. And then container is what you run on the operating system. Now, it is not truly equivalent to WORA, because WORA is true WORA, where you write it and you run it anywhere in the operating system. But in Docker, when you build the image, you have to specify the base operating system. And we'll get to that in a second. So when you specify the base operating system, if it's a Linux flavor, then it can run on a Linux operating system. Recently, they have started, well, not recently, but about a few months ago, they have added support for Windows Docker container. So if you're using Windows as a base image, it can only run on a Windows. But that still gives you a pretty wide range anyway. So what is the Docker mission at a very high level? Docker mission at a very high level is to be able to build distributed applications, ship distributed applications, and be able to run them in an effective way. And they have tool sets, they have tool chains in all of these three things. Anything that you look at coming from Docker is fitting in those three categories. It's build, it's ship, and it's run. And these are all distributed applications. They could run on your laptop, on your cloud, in your cloud, or on your on-prem data center. So it doesn't matter really. And the applications run in a very consistent way, independent of where they are running. Let's take a look at it at a very high level. How is Docker really different from traditional virtual machines? If you look on the left side, for example, I have my infrastructure on which I'm running a host operating system. On that host operating system, it's called as a host because it's host to something else. On that host operating system, I'm typically running a hypervisor, typically a type 2 hypervisor, maybe a bare metal hypervisor. And on that hypervisor, I could install multiple guest operating systems. So I have a MacBook. On a MacBook, for example, I could install multiple CentOS or Ubuntu or Windows, whatever I want. Now, if I want to run an application in that guest operating system, I will drop the application in there. But then the application is sitting in that guest operating system. That guest operating system is a full-blown operating system. So that's sort of the model that we are familiar with, that we are aware of on the left side. Take a look on the right side. I have the same infrastructure, and I have an operating system running over there. Now, this is not a host operating system. And on top of that operating system, I would run something called as a Docker engine. Now, if I were to package my application, there is no guest operating system. So instead of the guest operating system, which is full-blown operating system, I am using a base image of an operating system. And then my application, my binaries, and my libraries are packaged over there as image. Those images are then understood by Docker engine, which then runs the image as a container. So the difference is huge. So what it gives you is the density of the containers that can be packed on a machine, as opposed to the density of a guest operating system that can be run on a host. So let's talk about at a very high level, what does build, ship, and run really mean? Okay. Now, when you build, that's a Docker image. And if you're building a Docker image, all the instructions are specified in a text file, typically called as Docker file with a capital D. Now, as I talked about, there is a base operating system. So the first statement in a Docker file is the first non-comment instruction in the Docker file needs to be from, which specifies what is a base operating system. So it says, in this case, it says from Ubuntu. And then the last thing, typically the last thing that you would do in your Docker file would be a command. Docker containers can do one thing, and they do one thing really well. So in this case, you're saying, I'm using Ubuntu as a base operating system, and the command is echo hello world. And really, that's all is what it takes to get your basic hello world Docker file ready. So this is your Docker file, which will create an image. And we'll talk about how we create an image in a second. Let's take a little bit more elaborate example. Now, here I'm saying from Java. Well, Java is a standard Docker image that is available on Docker Hub. Now, this name recently got changed to OpenJDK, so I should update my slide for that. But essentially, you're using not a base operating system, but a more general purpose image, which has JDK installed in there. And that's the beauty of Docker. And there are lots of general purpose images on hub.docker.com, which you can use and build on top of them. That's a typical model that Docker recommends, that use a general purpose image, create an image that is useful for you, and then add components that you want to. Now, in this case, I'm saying from Java or OpenJDK, when the slides are updated, I'm likely have compiled a jar file using Maven, and then I'm dropping that jar file into user SRC. So in this case, I'm saying copy a file from the local file system into the container. So user SRC is a file system of the container. And then I'm saying CMD. I'm saying, because this is Java image, so Java CLI is included in the path. I can just say Java CP class, the jar file, and run the class. So that's it. So this is good, my very hello world Java example from the Docker perspective. Now, here you see a comprehensive list of commands that are available for the Docker file. I won't go into the details over here, but you can Google for Docker file syntax, and you will see that. This is sort of a broader Docker workflow that the way it works. There are three pieces to it. First is a client, then there is a Docker host, and then the last piece is really the registry. Now, registry is what we call as, say, Docker Hub. Could be a public or a private registry. So you could have a public registry, which is on hub.docker.com, or you could have a private registry, either by Docker or companies like JFrog or Artifactory, which supports hosting Docker images. So you can set up inside firewall, outside firewall, all of those combinations are possible. But now what you have is a bunch of images published on the registry. On the left side, where you see is a client, it's a dumb client. So, And in the middle, what you see is the Docker host, which is the Docker engine, which knows the commands to download an image, run a container, scale a container, all those things. Okay. So from the left side, the client gives the command Docker pull. I need a particular image, or rather Docker run. It says Docker run an image. And the moment you say Docker run, the client is configured to talk to Docker host. Docker host says, oh, I don't have the image that you want me to run. So I'm going to go talk to registry by default. I'm going to download that image from the registry, and I'm going to run the container on the host. And remember, I said the client is a dumb client, so there is nothing happening on the client. Client is just merely issuing requests to the Docker daemon running on the Docker host, and then all the containers, images, etc., are living on the Docker host. Now, for a typical development purpose, you will have the client and the host sitting on the same machine, as I do on my Mac here. But typically, when you go into a little bit more advanced stage of development, then you may start hosting your Docker host on Amazon or wherever you want to, and then you start playing with that accordingly. But the key flow is a client, a Docker host, and a registry are the three components that you require in order to play with it. Now, I downloaded a random image from Docker Hub. I don't know what it contains. How should I trust it? How should I verify it and stuff like that? So here I'm giving you the first command, so to say. I'm saying Docker images OpenJDK. So show me the OpenJDK images that are on my machine. And if you look at the second command, which says Docker history OpenJDK, that gives you more details about how the image was really built. So, and if you really start looking at the output, particularly on the last column, which says size, then you can see the first line is, oh, this is the base operating system. Then if you look at the third line, which is from the bottom, then it's talking about, oh, 44.3 and then 122.6. These are normal apt-get updates. And then if you go towards the top, then it shows, oh, this is where the actual JDK is being installed, which is about 349 megabytes. So you can start seeing how the image was built. And of course, you can see a lot more details about each and every command, as a matter of fact. From your purpose, you cared about, oh, I have an OpenJDK :8. Well, colon means is a tag of the image. So you're saying OpenJDK is the image name, and 8 in this case is the tag. By default, if you don't give a tag, the tag is the latest. So that's cool. So that's done. Now, OpenJDK 8 image, if you look at the Docker file for it, this would have a from, which would be from buildpack-deps :Jesse SEM, which is basically a flavor of Debian. Okay. And similarly, if you look for the Docker file for that, then you will see buildpack-deps :Jesse curl. If you look at the Docker file for that, you will see you'll see the from as Debian :Jesse. So essentially, even though you're using OpenJDK :8 as the base image, but it has a hierarchy of images that is going back all the way to Debian. So you know that this is a Debian-based image. And all of these images are collapsed using the union file system, which is a standard Linux concept. And that's what gives it the fast, because these images are read-only and they're collapsed. They give you a union view. And because the images are read-only, that makes the Docker container so damn fast to start. So even if, for example, you are deploying a WORA file in, say, Wildfly, you're not really dropping it into the file system. You're creating one more layer on top of it. And again, because of the union file system, it gives you the impression that, oh, everything is all into one file system. But because it's read-only, that gives the speed of the way which Docker containers get fired up. Another thing, I want to look at what images Couchbase has. And so I'm saying Docker images Couchbase. I can see Docker history Couchbase. So you can do that for any image that you download from the Docker Hub or any other registry, as a matter of fact. So what is the easiest way to start with Docker? Well, if you are on a Linux box, then Linux, of course, this is a native technology. So you can say sudo apt-get or yum install Docker engine, and it'll download the Docker engine and the CLI and all those things for you. But typically Mac and Windows, if that is your development environment, then you have Docker for Mac and Windows. It's a very native application here on a Mac with a very integrated UI. So in case of a Mac, I can literally do a Spotlight search and say Docker, and it'll fire up Docker, because that's how the application is being installed. It has the capability for auto update. So if there are new updates available, again, it gets automatically updated. There is no additional software required. I mean, earlier versions of Docker required you to have things like VirtualBox. Now, I will talk about that in a second, but you don't need that here anymore. So because what it relies upon is, if you are on a Mac, it relies upon hypervisor.framework, which is integrated into Mac OS X Yosemite. And if you're on Windows, it uses Hyper-V virtual machine. So it creates the right virtual machines using the software that is baked into the operating system. And that's why it got rid of dependency from VirtualBox. It's got a lot better networking and file system notification, and you can download it from docker.com/getdocker. So that will be the first step for you to start with Docker. Now, it has stringent requirements in terms of if you are using Mac OS X, then you need to have 10.10 plus. And if you're needing Windows, then you need Windows 10 64-bit at least. Now, we understand if you may not be able to meet these requirements, and we got a way for you. Now, on the right side, you see there is a Docker for Mac logo, Mac/Windows. I mean, I use Mac, so I use the terms synonymously. There is a stable channel by which you get general availability, which is a GA release of Docker. And then there is a beta channel where you can say, oh, give me all the bleeding edge features. So you got to pick your release for Docker for Mac and Windows accordingly, that you want a stable channel or you want an experimental channel in Docker parlance. So cool. You got started with Docker for Mac and Windows on your box, very easily. So you downloaded it, you built some applications. Now you want to scale it, take it into production. So that's exactly where Docker for AWS and Azure comes in. Well, what are these? Well, for Amazon Web Services, these are essentially Amazon CloudFormation templates. You get a link. You start a CloudFormation template. This is fully integrated with autoscaling, elastic load balancer, EBS storage, all of that. So you click through the wizard for CloudFormation. You say how many masters, how many slaves you want, and we'll talk about that architecture in a bit. But you essentially talk through that architecture. You click through the wizard to pick your number of masters and slaves, and that is the ability that you get by which you can install everything and have a cluster ready to go. Similarly, in Azure is integrated with VM scale sets for autoscaling, Azure load balancer, and Azure storage. So that's the beauty of it. Now, at this time, Docker for AWS and Azure is restricted availability, but you can apply for it at beta.docker.com. So Docker for Mac/Windows for development, Docker for AWS/Azure for your deployment stories. And here you see a snapshot of how do you create a CloudFormation stack on Amazon. And it sees that there is a template URL. You can see give it the name. In this case, there is one manager and three workers, and then you pick your keys, and then you create the template. So it's really, really simple on how you create this cluster for Docker engines very easily on AWS. Now, if you don't have those requirements met, particularly the one for Docker for Mac and Windows, then your starting point should really be Docker Toolbox. Docker Toolbox is one integrated package that you can download, which has most of the tools that you require typically for Docker development. Well, all the tools essentially. So you have Docker CLI, which is a binary. You have Docker Machine, which is the ability to create a host on your laptop or on cloud to simulate Docker host. And we'll talk about that in a second. Then you have Docker Compose, which gives you the ability to run a multi-container application. Then you have Kitematic, which is a graphical user interface. Then you also have the boot to Docker ISO, which is your ISO for creating the image for your virtual machine. And then VirtualBox, which is the type 2 hypervisor. So all of these tools are kind of loosely packaged up together in a Docker Toolbox. You download that toolbox, you fire it up, and it installs everything. And it even gives you a Docker shell. So that's pretty cool. The shell is pre-configured on how it needs to be done and how it needs to deal with that. So I think it's a really good starting point for you if you need something for get started. Let's take a look at Docker Machine for a second. So what is Docker Machine? Well, Docker Machine allows you to create Docker host on computer or cloud provider. It's a CLI. Once you install Docker Toolbox, what you get is a Docker machine, a CLI. It creates a default virtual machine for you, but essentially on a Mac or a Windows, you don't have native Linux capabilities, at least all of the ones that are required by Docker. Things like C groups and namespaces and all, those are required, and those are not available. So this virtual machine, essentially, it's a tiny Linux VM. It simulates those capabilities so that then that is configured as a Docker engine. If you don't have a virtual machine already created using Docker machine, then it's very simple. You can say Docker machine create, you give it a driver, and in this case, you are using VirtualBox as the driver, and you're giving it a machine name. Once you create it, then you configure your Docker client to talk to the host, create and pull images, start, stop, restart containers, and upgrade Docker as well, because Docker has a very good cadence of releasing every 4 to 6 months. And with that, you may want to upgrade the engine version, particularly on the server side. We show, the slides basically showed just one driver, which is VirtualBox. That is good for local development, but you may want to go for development on a cloud environment. And so Docker Machine actually has a whole bunch of providers that are available. So you can say Docker Machine, create my virtual machine on DigitalOcean or Google Cloud or EC2, wherever you want to create it. So that really gives you the flexibility on how easily you can do development on local machine. When you create Docker machine using VirtualBox and you want to go into production, then you say, oh, just create my virtual machine on the cloud now, and bam, there you go. Let's take a look at Docker Compose. So, okay, I got my single Docker engine, single Docker host, and I could run a container over there. Now, your typical application is where you need to run multiple containers. So Docker Compose is what allows you to define and run multi-container applications. You define the configuration in a single configuration file. The file is typically called as dockercompose.yaml. That's the default name. You're not restricted to that name, but it's a convention over configuration. And you can also have a dockercompose.override.yaml, which is again a default name that can be used to override the definitions in Docker Compose. And we'll look at it. Why is it relevant? When we are talking about impedance mismatch in a second. You can, of course, use multiple files specified using -f. So that's certainly possible. So you can have multiple Docker Compose files. And we'll talk about the use case for that in the next slide. But all paths in the Docker Compose file are related to the base configuration file. So if you want to build a Docker image as part of Compose, then you need to specify the paths accordingly. These are really good for dev, staging, and CI, and I'll show you the use cases for that.
Actually, Arun, we've got a couple of questions actually that are probably reasonably relevant here to interrupt you, if that's okay.
Yeah.
So one from Kata in IRC saying, besides installing the Toolbox, is there anything you need to run Docker Compose, any path variables or anything to be set?
No, so that's a good question. Now, when you install Docker Toolbox, it gives you a Docker shell, and that Docker shell is ready to roll. So all you need is have a dockercompose.yaml, and then you can say Docker Compose up, and that'll bring up all the services in the shell itself. So the recommended way, again, is to use Docker shell that comes with Docker Toolbox.
Okay. And you mentioned here that Docker Compose is great for dev, staging, and CI. In general, Kanshinji says that they're using Docker in their projects and they're completely happy with it in making their deployments easier, but they want to use it in their development process. What are the benefits of using things like this in development processes rather than deployment and production?
Yeah, I'll cover that in a second. I have a slide now, so
okay.
It seems like people are reading my slides already.
Perfect. Let's go on.
I'll cover that. Yeah, thank you. Thank you for asking those questions, guys. So now, if I want to run a Couchbase database, if I want to run the image, then I need to say, okay, I have an administration port, I have a query port, I have a memcached port. So I got all sorts of ports that need to be exposed for the Couchbase server. Containers are like diapers. You shit in them, you throw them, you bring a new one. But sometimes, in that shit, you want to scoop out some valuable information, particularly for a stateful container. So if Couchbase is a database, it's a stateful container. So I may wanna, well, I generally do, well, I always do map the volume. For example, because I know the default Couchbase container writes to OPT Couchbase WORA directory. So I wanna map it to my local drive so that even if the container goes away, I have the data in here. I can bring up a new container and do the same volume mapping and have the same data available in that container. Now, all of those things could be specified when I'm running the container on a command line. Or an easier way is I can specify them in the configuration file just the way here. I'm saying this is version 2. The containers, the Docker Compose file has a bunch of services. I'm giving it a service name as a DB. I give it the image name. I do my volume mapping. I do my port definition. And now I can just say Docker Compose up. That's it. That's going to bring up my service. So that's pretty clean and simple. But the real deal is where I want to run a multi-container application. Remember we said Docker containers can do only one thing at a time, and they really do that well. So essentially, I'm running my Wildfly container separately, and I'm running my Couchbase container separately. But I want them to be able to talk to each other, or I want to be able to curl to Wildfly, say, OK, show me a REST API where I want to use CRUD on top of a Couchbase database. OK. So here's how my application, my Compose file would look like for that. So in this case, I have 2 services, DB and a web service. DB service is pretty clean. It's very simple. And here I'm saying the image name is the same, ports is the same. In the web, I'm using a custom image, Arun Gupta /Wildfly, because this is essentially where I've packaged up my application already. This is based upon what we discussed earlier. And the key part here is I'm saying in my environment, I'm defining a new environment variable called as Couchbase URI underscore URI equals DB. And DB is a service name, essentially. I'm exposing my ports of Wildfly as well. But again, the key part is when a Java application deployed in our application server is talking to a database, it needs the host and port information at least. Sometimes the port could be default, which is the case here. So I could say, I just need at least the host. So the beauty of services is I can just point to the service name, and using the internal DNS lookup, Docker will automatically resolve DB to the right container IP address. So to me, it's very seamless. I'm talking at a very abstract, logical level that, yeah, web service needs to talk to the DB service, and they can talk. Whatever the IP address is, wherever you're running, it's up to you. Go figure it out. So let's take a little bit more. Overriding services. Now here, I'm looking at a simple Compose file. It's one service. The name is web. It's using the image, and it's exposing a port. Okay. Now let's say if I have a Docker compose.override.yaml in this case. Because I'm using the same name, it's going to override the definition for that. And it's not overriding everything. It's saying keep the image exactly same, but I just want the port to be changed. So I'm saying on the host, port is going to be 9080, and the container port is going to be 8080. So now if I run this file together, in a directory, if I have these 2 files, and I say Docker compose up, Wildfly is going to be exposed on port 9080. And I would generally do -D because I want to run my Docker containers in the background in a detached mode, so to say. Let's take a look at dev prod. How would you reduce that sort of impedance mismatch, essentially, that we were talking about earlier. Now, in this case, I have 2 images or 2 services, DB dev and web. Okay? And DB dev is using a custom image, which is Arun Gupta /Couchbase. This is the image ready to use that is pre-configured for a sample bucket and all those things. And in the web, I'm using, again, saying Couchbase URI, and I'm saying db-dev :8093, which is a query port for Couchbase. Okay. So that works because the service name is like that. Now, let's say I have another file called as production.yaml. So that is OK for my development part of it, and I can quickly bring up my development environment. Now, when I go to production, I have this production.yaml. And in the production.yaml, essentially, I have db prod, first of all. And db prod could be a different image or maybe the same image, configured a little bit differently. And then the port is also, instead of 8080 for web, I'm exposing port 80 because typically, you don't want the port to be exposed. So you just say hit on a local host, and I should be able to see the page. So you change the port also. Now you can run these. If these 2 files are in the same directory, you can just say Docker compose up specify the docker compose.yaml, that is your base file, and then you can also specify the production.yaml, in which case the services will override. So you can see how you can do your impedance mismatch, where keep all the things that are common in your docker compose.yaml and yet override them with production.yaml when you're going into production. So going back to the question that you asked earlier on how does it help in the development environment? Well, that is actually the biggest use case, as a matter of fact, for Docker Compose. If you have, imagine, a new developer comes on board, and you say, all right, here is my project. Typically, you'll say, here you go git clone this, build this WAR file, download the internet over Maven, and do 500 other things. Download this tool, that tool, and then you're ready to go. As opposed to, imagine you say, here is this docker compose.yaml. Here are these 10 services defined in it. You just do docker compose up. It's going to download Wildfly server with the WAR file baked in. It's going to download your database. It's going to make sure the Wildfly and the database are configured to talk to each other. All of that configuration could be done for you automatically. So the beauty is you can use that setup for doing your dev setup. And then the wonderful part is how you can take that entire dev setup and move it to production as well, just by changing maybe a few environment variables depending upon how you have configured your Docker Compose scripts. You can target a Docker Compose file to a local host, which is like you configure using Docker Machine or Docker for Mac, or you can target it to a remote host just by changing a few environment variables. You can Docker Compose, and we'll talk about Swarm a little bit later, but Swarm is essentially a cluster of Docker engines. So you can target Docker Compose to a single host, which is a fundamental flaw or a single point of failure in a distributed architecture, or you can say, I'm going to target it to multiple hosts. So it's integrated with Swarm. Another advantage, particularly on the dev side, is how you can have multiple isolated environments. When you say Docker Compose up, by default, it chooses a directory name, and it creates a project with that, and it creates all the services in that namespace. You can create multiple isolated environments, let's say one for each branch, as a matter of fact. You can say Docker Compose up -project and give it a branch name and start passing environment variables. So you can start specifying environment variables. Those environment variables are then read into your Docker Compose file, and they do all the building, etc., what needs to be done. Another use case, particularly for during development time, is how you can do, it's really seamless, how you can do Docker Compose up, run your tests, and Docker Compose down. All seamlessly done in a very easy way. So I think these are some of the use cases. And last but not the least, we talked about it. How does it help you with the dev prod impedance mismatch? So you can keep using exactly same images, just change the ports, just change the environment variables, and it'll help you reduce the impedance mismatch. So far we have looked at Docker Engine, which is one host. Then we looked at multi-container application on that host. But as we said, this is a single point of failure for a distributed architecture. So that's exactly where Swarm mode comes in. Swarm mode is what gives you the ability to run multi-container application on a multi-host. Swarm mode is it's a brand new feature in Docker 1.12, which was actually released about a couple of months ago only at DockerCon. The feature was released a couple of months ago, but it has been into community testing for a long time. But essentially, what Swarm mode gives you is the ability to manage a cluster of Docker engines. It's an optional feature, so you need to explicitly actually enable it. But once you have enabled it, then you can use Docker CLI to create a swarm, deploy the apps, and manage the swarm cluster as well. It is self-organizing and self-healing in the sense that you can create a service in Swarm, and you can set the desired state of the service that I want to have 4 containers running as part of this service. If a container goes down, the Swarm will automatically bring up that container on a different host or maybe on the same host. If a node goes down, it'll give you a notification, and then you can act upon it, and it'll automatically reschedule the container for you. So in that sense, it's self-organizing and self-healing. It also cuts down your single point of failure, because now your nodes, or containers rather, are not deployed on a single node. We talked about how it gives you desired state reconciliation. If the desired and the actual are not matching, and I'll show some demos of that. It also has the ability by which you can scale your services. Oh, I want, instead of 3 instances, I want 5 instances. So that's pretty cool. It also has the capability for rolling updates. And we talked about this. This is an optional feature, backwards compatible, and it need to be explicitly enabled. So let's take a look at it. Instead of doing live demos, which could take longer, I thought I will animate it. I'll show the demo using this animation here. So let's say you have a single host configured, and I'm saying Docker swarm init. So that needs to be explicitly enabled. You can specify an IP address where it's going to listen for the request. And you can either give it a secret, or you can optionally say, you know what, you generate a secret for me. So now I have a single node swarm cluster, okay? By default, the first node is always the, no, not by default. The first node in the swarm cluster is always a master, okay? Then you can say, all right, Docker swarm join. You bring up a second node, and you can say, I want to join that cluster. So that one master is available. The worker, it's not a master slave, it's a master worker environment. So the worker will now join that master, okay? Similarly, you can have multiple workers join the swarm cluster. So now this is a 6-node cluster with 1 manager and 5 workers. Manager is primarily for administrative purpose, although by default you can run containers on the manager as well. You have an option to configure manager to be a pure manager with no containers running on it. There is an option for having a primary versus secondary master. So you can set up, a cluster of masters and a cluster of workers. Any request that goes to the master is automatically, or any request that goes to the secondary master is automatically proxied to the primary. And they work in, if the master goes down, or if the primary goes down, the secondary automatically becomes a primary in that case. So I want to set up a swarm mode using Docker machine. So let me kind of walk you through what those steps would look like. Well, I would say I will create a machine. I'll say Docker machine create. I'm giving the VirtualBox driver, and I'm going to create a manager, say manager X. And X could be 1, 2, 3. You can create multiple managers like that, okay? Then you're going to create that many Docker machines for worker X. So you got, depending upon how many you want and how much you want, you got to create that many machines. Now on the manager, you can say Docker swarm init. You can give it a listen address and an advertise address. On the master, it'll give you a manager token and a worker token. So you got to identify what the manager token is going to be and what the worker token is going to be. These tokens are then used by the virtual machines, the Docker machines rather, to join the cluster. Okay. So now manager X has to join, so you give it a manager token. And when manager or the worker X needs to join, then you give it a worker token. So depending upon which node is joining, you give it that particular token, and they become part of the cluster. So that's it. That's all it takes to create a very simple cluster of Docker engines enabled with swarm mode. And I create this quite regularly. On the bottom of the screen, you will see a URL, which is on github.com/docker/labs, where I contributed a script on how you can take the script, run it, and it'll automatically build a container or a cluster for you. Now, if you look at this, this is the managers are configured in a Raft consensus group, okay? And what that means is that gives you the ability to have one leader, and if that leader goes down, then they consult among themselves and promote one of the secondaries to be the primary. And it's a strongly consistent protocol. So it kind of gives you the ability that, okay, it's going to have a consistent shared state across the cluster. And then on the bottom where you see is the workers, these workers are talking to each other using gossip network. Essentially, your services will span across multiple workers, and your containers will be running in that service. So all the red containers essentially form one service, all the green containers essentially form one service, and that gives you the ability where you don't have a single point of failure for your service. One of the questions that people ask me all the time is, how do you run, what is the scale by which swarm mode can scale into production? So here is, now I'm one of the Docker captains, and Docker captains are like Java champions or NetBeans Dream Team members or whatever those community champions are. But one of the Docker captains ran this test, so there they were able to run about 2,400 nodes configured in a swarm mode cluster. Okay, 2,400 nodes configured in a swarm mode cluster, and they were able to run up to 100,000 containers on it. Now, hopefully you're not building that big containers. No, I mean, that many containers are running on that big a cluster. Hopefully you have a lot more smaller clusters. But just to kind of show you the capability, what is possible with swarm mode in production. I think that is pretty impressive. And again, at the bottom, you can see more details about how this was configured and what was done. I'm going to skip this slide. So come here. Now, I have a swarm mode cluster setup. Okay. On that swarm mode cluster, I want to create a service. Okay. How will I create a service? I will say Docker service create, give me 3 replicas. So, and you give it a name, and it's going to spin up 3 replicas automatically. It will pick up a random strategy on where the containers need to start, and it will start them. Okay. So I'm going to skip this slide. I'm going to move on here. Now remember, this is typically given as a 2-hour presentation, so I'm skipping some slides, but I'm giving enough context anyway. Now, one of the beauties that is there in Docker Swarm mode particularly is how your load balancers are typically host aware. They're not container aware. But with Docker Swarm mode, it has an internal routing mesh, and what that means is if your request comes into load balancer, it can send the request to any of the nodes in the swarm mode cluster. And if the node is not serving that particular container at that point of time, it will just auto forward it to the container to the host that is actually serving it. So from your perspective, your load balancer is configured to talk to all the hosts. The Docker Swarm mode is fairly independent to move the containers around across different nodes, but your application is still accessible. Now, let's say a common failure that can happen is a node fails. Okay, a node fails. Swarm mode says the desired is not equal to actual. So it reconciles the state. Node has gone down. You go figure out what happened to the node. You can fix the node, but Swarm mode will make sure the container is automatically scheduled on a different host. Now, let's say although Swarm mode will figure that out, reconcile the state, and it will run the container on a different host. Okay. So at a given point of time, you have a desired and actual state reconciliation that's happening, and if they're not matching, then it does occur. How do I scale my service? Scaling is very simple. I say Docker service scale. I give it a service name, and I say scale it to 6, and boom, boom, boom. Docker automatically spins up that many more containers for you. What we talked about was a replicated service. There is a concept of global service in Swarm mode as well. Global service is typically required. Let's say you want to run a singleton instance of a service on each node of the cluster. Prometheus, for example, is a prominent logger that is used by containers. So let's say you want to run a single instance of Prometheus on each of the hosts, the node or the host. Yes, you can do that, but you just need to specify the mode in this case. There is also this concept of by which you can take the node passive. And what that means is, let's say you find that a particular node is not behaving correctly, or there's some memory problems, or some sort of a debugging that needs to be done. So you can take the node passive. The containers will keep running on that node. You can debug what's happening over there. And then eventually, once you have fixed the problem, you can bring it part of the cluster. Okay, so that's the important part to understand. Now, you can also, once you have made the node active, now let's say you want to upgrade a node. Let's say you want to add more memory or replace with a new VM or whatever you want to do. So then you can drain the node. As soon as you drain the node, it says, oh, you're draining the node, so the container needs to be rescheduled. So it reschedules the container on a different node. Okay, once the container is rescheduled, and in this case on the bottom node, and once the container is rescheduled, the drain is out, the node is out. You can upgrade whatever you want to do, and you can bring it back at a later point of time. Let's take a look at it. How do we do rolling updates with Docker Swarm mode? Okay, so now in this case, I have 6 Wildfly instances running on 5 nodes. Okay, so the command at the bottom, I'm saying Docker service update web. I'm saying, okay, use the image with Wildfly:2. That's the version number that I'm going to use. So Wildfly:1 was my custom image that I used. So I'm going to use Wildfly:2 in this case. And I'm saying update parallelism. That means update 2 containers at a given point of time. That's what the parameter mean. And I'm saying update delay is 10 seconds. That means after a first lot is done, wait for 10 seconds, and then you update the next one, and then you update the next one, and so on. Okay. So in this case, essentially what will happen is it'll update 2 containers, wait for 10 seconds. It'll update next 2 containers, wait for 10 seconds, and then the final 2 containers are updated. So this is sort of a rolling update that will work very well without bringing your application down. So that's a pretty cool feature as well. Another cool feature that you want to understand, particularly that is very relevant from the Swarm mode perspective, is how each Docker host or Docker node could be assigned labels. So you can assign labels. In this case, I'm saying Wildfly:storage equals SSD on the 2 nodes on the far right. Okay, to the Docker daemon, I've assigned these labels. Now, when I'm running my server, I can say, okay, when I'm running my container, I can specify the constraints that, okay, run these containers only on the hosts that have these labels. So the constraints and labels really match with each other. That's very important to understand. Okay. Now, if I scale the service, it's going to stay within those hosts itself. And now, if I create a database service, Couchbase, for example, is going to say, okay, I'm going to look for nodes that don't have those labels. So it's going to spin up on the 3 other nodes. So I'm going to skip this slide. So one of the classic use cases for this is we found this, how our customers are using is using Couchbase multi-dimensional scaling. Now, Couchbase, in a database, typically you have 3 aspects. There is a query, index, and data service. The needs for each of those services are very different. So what you would do is you would set up multiple nodes. Each node could have, some nodes could be CPU intensive, some nodes could be disk intensive, some nodes could be memory intensive with fast read-write. And essentially, those are the requirements for each of the service in the Couchbase cluster. Couchbase can be easily configured as a scalable cluster using Docker containers. But each service can scale independently as well. So now what you can do is you can attach labels to each of the Docker hosts. And when you're running the containers, you can say, oh, I only want to run a query service here. So start up a container which is configured for query service, or start up a container that is configured for index service, or start up a container that is configured for data service, because I know I have labeled the Docker hosts accordingly. And so I want to run only those relevant containers. So that really allows you to have some custom scheduler algorithms, and also how you can effective utilization of your resources. So a little bit more advanced example here. I wanted to run a cluster of Couchbase using Docker services. So, all right. Couchbase, again, as I said, is a homogeneous cluster. That means there is no concept of master slave over there, unlike other NoSQL databases, which tend to fail more often. Now, in Couchbase, it's a homogeneous cluster. And so what I'm doing here is the typical cluster creation process is you spin up a bunch of nodes. Then you pick any one node, and you add other nodes to this node and say, all right, now you form a cluster. And then it becomes, again, a homogeneous cluster. So just for automation purposes, I said, okay, you know what? I'm going to create a master service, and I'm going to create a worker service. Because master service, it gives me the ability that it's going to make sure that the desired versus actual state going to stay constant. So it will only have one replica, and that is primarily to create the cluster, so that it's an entry point to the cluster. And then I have a worker service that I can scale as much as I want to. So then I create a worker service. Every time a node in the worker server comes up, it says, oh, I'm going to go talk to the master and register myself as a worker. But then the entire cluster still is very homogeneous. So I think that's another interesting part to understand. If you look at the blog on the bottom, you'll see more details about how did I create a Couchbase cluster using Docker services. So let me kind of see what other slides are relevant to talk here. There is a lot more that we can do. Maybe a couple of more slides here, and then I will jump to another last slide. So here, for example, if you think about the Docker lifecycle, a typical Docker lifecycle is, you take a Docker file. From the Docker file, you create an image, and from the image, you create a container or a bunch of containers. That's your typical Docker lifecycle. Now with Docker 112, Docker file is a single service image description. Image is a single service distributable image format, and container is again a single service runtime format. But our typical application is multi-container. So that's exactly what is, Docker build and Docker run. Yeah, okay. Now, this is an experimental feature, as I talked about. Remember Docker for Mac and Windows? You can download the experimental channel. So what it is in a Docker Compose, it gives you a multi-service image description. Using the experimental Docker, you can create a multi-service image format, which is a distributed application bundle, or commonly called as DAB. And then those could be deployed as stack. It's a multi-service runtime format. So the way it works is you say Docker Compose build, that's going to give you a DAB. And then you say Docker deploy, and it's going to give you a stack. And those services can scale. I won't go into the detail over here. It's an experimental feature, but that's something I've played around with. And I think it's worth looking at it, because that's sort of the future direction where Docker is headed to. Now, this is a very classical use case on how people set up their CI/CD pipelines with Docker and Jenkins. And I should maybe add a blog URL for this as well in the slides. But the idea here is, if you look at it, there's a developer. Every time he does a git push to the Git server, Jenkins is configured to read that data on either as a webhook or a poll. It clones a workspace. It creates an image. It runs a test on that image. And if the tests pass, it pushes that image to Docker Hub. Now, it could be a Docker Hub. It could be a private registry, or it could be a private registry on Docker Hub. Either way. But the point being, all of this setup can be done. And with Jenkins 2.0 particularly, they have this Jenkins file as a DSL that can be used to very easily configure different stages. And I blogged about it. And if you go to my blog, blog.couchbase.com, look for my name over there, and you can find it over there. But there are complete instructions on how you can easily set it up. And I will include a link to the blog on my slides anyway as well. And I think we're almost out of time, so maybe I'll just go to the last slide here. This is a book that I wrote, Docker for Java developers. This is a book on O'Reilly.com website. It's getting updated. I mean, it's actually got updated, and the link should be available in the next couple of days. So this is a free book, but you should be able to download it. And then something else related to it, and Simon and I were talking about it. I will schedule something on this topic. What we look today is only Docker stack. Docker Swarm gives you an orchestration framework, but Kubernetes is an equally competitive orchestration framework. So I'm going to be delivering Kubernetes for Java developers training for O'Reilly on September 23rd. So I would say pick, if you want to look for Docker stack, look over here. If you want to look for the Kubernetes stack, then join my training. And then we will probably do a virtual jog session as well. All the slides are already available on github.com/docker/labs. There is a hands-on workshop for Docker for Java developers, github.com/docker/labs again. And I would give a huge props to Docker docs, docs.docker.com, where some excellent amount of content is available. All right.
Awesome. Thank you very, very much, Arun. That was an awesome presentation, as usual. We've got some questions in. Let me grab some questions. Okay. So Monksy asks, I don't think we answered this one. How do we connect to other Docker containers from one container to the other without linking the containers?
Yeah. So Docker linking is an obsolete terminology now. Nobody uses linking anymore because linking is now replaced by what they call as Docker overlay networks. And with overlay networks, well, by default, when you spin up containers, they run in a bridge network on which they can talk only on the host. But typically, when you have a multi-host application, then you have these whole bunch of containers running across multiple hosts. So then you need to set up a Docker overlay network. And then remember the way I was showing, I was using those environment variables and saying, give it a pointer to the service. And so you will say, okay, you know what? I don't care where the service is running in the cluster on which host. Just point me to the service, and Docker will take care of the DNS resolution, and I'm going to use service as a logical name.
Okay, awesome. One question from JX Bloom, interesting question that was answered in RC, but it's worth mentioning online as well. How does Docker know that two separate services should run in two different containers? And this is really from the YAML that you were creating.
Yeah, so there are other, one of the things we didn't cover today, we didn't have time to cover today, is how you can start associating affinity to containers. That my DB container has a closer affinity with the Wildfly container, then that is a hint to Docker that, okay, run them on the same container. Ideally, you want to create an affinity if there is a strong reason for it, but essentially, as a good architecture practice, because you want to give the flexibility to Docker to be able to reschedule your containers on the right host at the right time. So you don't want to create that affinity.
And in Docker, in your Docker Compose YAML file, of course, every label with a colon after it, that will be created as in a Docker container, right?
Correct.
Awesome. Question from C.Doremus or CDO Remus, depending on if they're a Java person, I guess. Why use Swarm if AWS Azure automatically scales? I guess this is maybe a wider question. Why use Swarm or Kubernetes or Azure? Which one would you pick for which reasons?
Yeah, so I think if you're looking at containers, essentially you're looking at multiple orchestration frameworks. There is Docker Swarm mode, definitely. There is Kubernetes. There is Mesos. There is Amazon ECS or Elastic Container Service. So yes, Amazon scales, but you need to pick one of these orchestration frameworks first. Then, in order to run these orchestration frameworks, you need to pick a cloud provider. That cloud provider could be, Amazon or Google Cloud or whatever. Pick your on-premise data center. So I think that's the combination that you're really looking at it. So because if you want your containers to scale, you have to pick the right orchestration framework. And right is a very subjective word here. But if you look at Docker for AWS, it really leverages that Amazon ELB, elastic scaling, auto scaling groups. So let me give you a concrete example. Let's say you configure a Swarm mode cluster on AWS. If a node goes down because it is connected with Docker auto scaling, it will automatically bring the node back up for you.
Okay. C.Doremus asks, where is the local Java source code in these Docker Compose configs?
The Docker Compose, remember, in the Docker Compose, you are specifying an image name. And the image name is typically pulled from either Docker Hub or a private registry. So essentially what you're doing is, I showed that CI/CD pipeline. So essentially you have a Jenkins server running somewhere where as soon as Git commits something and it builds the whole thing out and it pushes everything to the registry, and Docker Compose only cares with the image name itself. And the image name has either a WAR file baked in or some mechanism to get that WAR file.
Okay. And one final question from Shorang. How do you pass external host IPs to Docker services? Follows on to say Docker run has -- add hosts, and Docker Composed has external hosts, but the application bundle doesn't support it.
Yeah, so I think I would say application bundle is, again, as I said, is an experimental feature. And if you see anything is missing, typically the experimental feature in one release will be GA'd in the next release, so likely in 1.13. And if you see any feature is missing, absolutely file the bug on that.
Awesome. So that's all the questions that we've got. So it just leaves me to say thank you very, very much, Arun, for another awesome session. And also, thank you very much for supporting the Virtual Jug, Arun, because I know you do a lot for the Virtual Jug, and not just speaking, but in the background as well. And to Arun is obviously the VP. I probably should have said this at the start. Arun is the VP of Developer Advocacy for Couchbase, one of the Virtual Jug sponsors as well for VJug 24. So thanks to Couchbase for being a gold sponsor and for really helping us in supporting the VJug 24. Just one thing I'll mention really before we go. VJug 24 is on the 27th of September. So if you haven't RSVP'd to that, do check that out. Go to the meetup.com/virtualjug or vjug24.com, and you'll be able to get a bunch more information on that. At Virtual Jug on Twitter is just about to tweet the replay for this session, so that's available straight away, and you can watch that on the Virtual Jug site. I think that's everything that we have to say. Anything more from Arun or Oleg?
I'm good.
Awesome. And if you wanted to, awesome. And if you wanted to follow Arun, at Arun Gupta on Twitter, do follow Arun and have a chat. If you have any further questions after this, please do reach out to Arun. He's more than happy to help out with you.
Always. Thank you so much for having me here.
No problem. And thanks everyone for joining today. And see you on, well, hopefully see you either at Java 1 or on the next VJug, which is going to be VJug 24. See you later, guys.
Bye, guys.
Bye-bye.